Yes. Yes, good. What the application of catalytic olefin metathesis?
Catalytic olefin metathesis.
Yes, what is the application of catalytic olefin metathesis?
Generally, this metathesis reaction is generally widely used in the polymerization reaction to form the polymer from the strain system, because at the when a double bond or ring was opened, the it generally give one isolated double bond and give the MLN site into the inductor. This MLN, that is the metal, it was inserted into the system, and that can react with the further molecule to form chain. So this is the main application, the catalytic AM reactions, olefin metathesis reaction.
Yes, good. Yeah, next move on. Next topic is coupling reaction. What is coupling reaction? Can you explain? How many types
The
of coupling
coupling
reaction?
reaction is generally it's a coupling reactions where the in presence of a organometallic reagent, generally the platinum or the palladium, there is a coupling between the alkyl halide with some other moiety. It is called, I guess, there is a popular kind of reaction like Suzuki coupling,
Yes.
Negishi coupling.
Hack
Fukunaga coupling
reaction,
is all.
hack reaction, steel
There's
coupling,
the still like the Negishi, Hiyama, then Hartig.
Yama.
So
Yes, Yama.
Hartig also there. So
What is cross coupling?
in the cross coupling, generally two different alkene groups, it's generally one is the alkyl halide that was different, has bearing different moiety, and another one side the coupling reagent that has different moiety. Like if we have a if we I'm writing the reactions and one, then I can so this is the generally example of a Yama coupling. This is the example of cross coupling set.
Yes.
Like here the RX and the this reactions is different. Like to define molecule, that's called the coupling reaction.
Yes. What the main application of coupling and cross coupling reactions?
It's very much widely used in the CC bond formations in the organic chemistry. We can generally synthesize the or any kind of bond between these two moiety through this cross coupling reaction. So it is widely used in the pharmaceuticals.
Yes. The next move on. Next topic is olefin polymerization. What is olefin polymerization?
Olefin polymerization. So, yeah.
Yes.
The generally olefin polymerization is generally done using the Ziegler-Natta catalyst. So the one, if we take the one ethylene molecule, this ethylene molecules polymerize in case of the Ziegler-Natta catalyst. The catalyst is titanium Cl4 and AlETO3. So this is the cell.
Yes. Polythene, polypropylene, Ziegler-Natta catalyst is olefin
Titanium
polymerization.
silver and AlPt3.
Yes. What is Ziegler-Natta catalyst? Explain. Any example of?
Yes, sir. The catalyst is generally first react with the titanium silver with aluminum Et3 to give the TiET5 with a vacant site, and this vacant site generally responsible for the further polymerization.
What's the difference between polymerization and oligopolymerization? Oligomerization reactions. Any basic difference?
Basic difference between polymerization and oligopolymerization.
Yes.
No, sir, I don't know.
What is yes, you look them. Metallocene catalyst. What is metallocene catalyst?
Generally, the metallocene sometimes generally titanosin is also there with a cyclopropyl. This bent metallocene generally do the polymerizations. The one of the popular example of that I'm writing
Yes.
there. Yeah. So this is the one of the popular catalysts of zirconium, and also titanium can be used in the absence of the zirconium. This one generally used for the polymerization reactions.
Yes. Yes, good. Next, move on ferrocenes. What is ferrocene? What is the main application of ferrocenes in OMC?
The ferrocenes generally the iron was generally sandwiched between the molecule and other is in the plus two or oxidation state. So this is the ferrocene molecule compound, and ferrocene is generally diamagnetic in nature. So, and the main applications of the ferrocene is that we can generally there is a cyclopentadiene ring which is aromatic in nature. Okay, but when the iron was generally attached to it, so its aromaticity is decreased. So then this ring can participate in both the electrophilic and neutrophilic reactions for the substituting the five-member ring of the pentadiene. It was generally used.
Any basic reaction of ferrocenes?
Yes, I am writing, sir. So, or lithination can be done on the ferrocene, on the cyclopentadienyl of the ring we are using the NBULI and the TMED as a chelating agent. So I am writing this one. So this is the one reactions using the ferrocenes and the TMED.
Yes. Yes, good. Any MO diagram of ferrocene?
The entire one I can draw, but the whole that I can't draw, sir. I'm drawing, sir.
An interaction of CP molecules in metal.
Yes. So this is the MO diagram of the Fonter MO diagram of this ferrous molecules. Like E1G is the homo, sorry, A1G
Yes.
is the homo, and 1G star is the LUMO here. If you consider the iron, so there is a 6 electron, and all the bonding was generally bonding electron generally occupy the bonding orbital, so 6 electron.
How many basic reactions of ferrocenes with interact to any yields?
It can undergo a different type of reactions like aromatic nitrations, even oxidations of the ferrocene take place in presence of the acid like HNO3I2. These are the compound. Apart from that, the ortholysinations that I have shown, sir, nitrations, all these reactions, both the electrophilic and nucleophilic substitutions is taken place in the ferrocene complex, in the cyclopentadiene of the ferrocene complex, sir.
Any relation between ferrocene and CFSE, and any relation between ferrocene and NMR spectroscopy?
Yes, sir. In the ferrocene generally give one picture because here generally the all the cyclopentadiene link is equalized by the movement of the metal atom through it. So it only give only one singlet in the American, but it is not a fluxional molecule.
Yes. What the difference between chiral ferrocene and achiral ferrocenes?
Metal ferrocenes and achiral ferrocenes. In the ferrocene, generally there is a sigma plane because it is in the eclipse conformations. If we do the one substitution into the ring, only one ring, then the sigma symmetry was completely lost and it become the chiral. So here I am showing this reaction. Suppose if we consider this methyl, if we consider this compound and if we attach one methyl uh, by reacting methyl iodide with N-Bewley substituted, then it is become the chiral one, sir. That I have said here, mentioned this one, sir.
Yes, good. What is HGL chirality in ferrocenes? Any example?
Sir, sorry, sir, can you please repeat?
HGL chirality in ferrocene. How to representation of axial chirality in Kerosene.
Axial chirality, sir.
Yes.
This chirality, if we substitute one ring, it become chiral because there is no sigma plane. Axial chirality. Like axial chirality, this type of chirality is shown by the allene type molecule. So if you compare this molecule with allene, then we can find some similarities. So if we like consider this iron and this two phenyl ring as a backbone, sir, this phenyl ring as a backbone, then if you want this methyl ring, the methyl substituted this one was on the different. So this is the one type of chirality that I can compare like with allene. If we compare the both structure in this way, like the backbone was made up of cyclopentadienyl iron and cyclopentadienyl.
Yes. Any limitation of ferrocenes in OMC, organometallic chemistry?
Limitations are this is the one of the limitations that's in presence of the air, that is the oxidation by oxygen generally oxidize this iron into the plus three. So then its color changes from orange to I think different color because then the iron become iron to the iron. So this is the one. Otherwise, it was generally has lots of applications like it has used in the fuel to reduce the smoke emission. Also, electron transfer reactions different. Sir.
Yes. One term used in kerosenes, Ugi method. Ugi's
Yes,
method.
sir.
Ugi's amine. What the meaning of this word?
So the Woogie amine is the generally substitution of some amine group into the, yeah, I'm sir writing sir, the reaction.
Yes.
This is the sir whole scheme. This is the final product, sir. This one. This one.
Yes.
Like the formulations first take place, followed by the manic reaction. Simply. And this is called the Woogie's man.
Is good. Next, what is organometallic polymer?
Organometallic polymer. It's an organometallic polymeric reagent,
Yes.
like the Ziegler data catalyst. This one.
Ziegler-Natta catalyst is the olefin polymerization example of organometallic
Yes, yes, sir.
polymers. How many types of polymers in organometallic polymers?
Organometallic polymers, sir. I don't like depend of carbonyl. This all these things. Sir.
Kerosene-based condensation polymer.
Yeah, like sir, the if we have sir different like manganese, if we use sir, I'm writing one structure that I've read. If we like manganese, all these things are present as a polymer in the A, but ferrocene as a present as a like and right drawing. Sir. Titanium also sometimes shows. Sir.
Yes.
Manganese also shown in the solid state, all these things. Sir. So if you consider the solid state structure of manganese, it's generally polymerized, and this is generally polymeric in solid state. So it is contain the infinite number of chain. The main reason for this is the electronic configuration that is of high. So that's why it can't get stabilized because of zero CFSE. So this got stability through the polymerization reaction, sir. So this is the reaction of the manganese. And titanium also sometimes shows some tiny nuclear structures, sir.
Yes. Good. What is oxidative coupling in or metallic polymerization?
In the oxidative coupling, generally what happened? That is like oxidative addition, one of the sir, reactions, sir. But oxidative coupling, sir, I didn't. It's,
Oxidative coupling in presence of organometallic polymerizations. Dehydrogenations.
yes, sir. The squat region is generally used for the hydrogenation reactions. So this is the structure, sir. Hydrogen chloride, then Cp, ring, then polymer is there. So this is the hydrogenation reactions. Do some oxidative reaction to give our desired product. So this is the one squat region. This is called. It's generally one of the bent sandwich compound. It generally hydrogenates. Is it visible, sir?
Yes, yes.
And we can oxidize also further like carbonyl. Then it got undergo oxidations, but it's addition like carbonyl. Then if we react this compound further with the carbonyl, then one aldehyde generally from other ketone. So this is the one of the example of cell oxidative.
Yes, good. What the difference between ring opening polymerization and ring closing polymerization? Any example?
But this is the one of the example that I have shown sir previously. This is the one example. I'm just showing. Here, sir. This is the ring opening polymerization. They had the non-bonding ring from polymer. So this one, sir, like this one.
Yes.
And the above one is the sir ring closing, sir. Presence.
What is ferroso fence?
What is sir? So fence means. Can you please repeat?
Yes, yes,
Okay.
ferrocino fence polymerization. What the relation between ferrocino fence with IR, UV spectroscopy, UV visible spectroscopy, NMR?
The IRNTOP. Like sir, if we do the polymerization reactions of ethylene using the ferrocene, sir, the double bond stretching frequency is generally decreased. So this can be, suppose double bond shows one frequency at around 1680 centimeter inverse, but when it is converted to the polymers, the double bond character decrease. So there is a shift of the stretching frequency will be the less. So in this way, we can generally monitor the polymerization reactions.
Yes, mostly topic is covered in OMC. The next question regarding to OMC is what the uses of organometallic chemistry in our society and human being?
In the society like Walker reactions, the Wilkinson catalyst, these are all the widely used in the industry level for for doing the hydrogenation reactions, and their activity is very very high. And the Ziegler natural catalyst is one of the most important catalysts in the polymer industry. Other water gas shift reactions, uh, the uh, the cracking of the alkenes using the zinc copper oxide, this type of catalyst are done using the organometallic chemistry. Also, the cisplatin, one of the example that shows anti-cancer, acts as anti-cancer drug. This is the one example on the human life, sir.
And what is the uses of metal carbonyl, metal nitrosyl?
Yes, a metal carbonyl, these are all generally used for the preparant reactions like hydroformylation reactions like COCO4. Metal nitrosyls is generally studied with the what that is called. Sometimes the inorganic is compared with the hemoglobin through the binding their studies is early transferred because the nitrosyl is important and signaling molecule in the our body. So this can be traced using the organometrics compounds.
Yes, good. And what are the uses of metal carbines or carbene, fissile carbene, and metal carbines? What are the uses in human being?
It's a metal carbon carbines. At this moment, I can't remember, but so they in the synthesis, organic synthesis, it should have used because we can just substitute this metal carbon within another moiety to get our alkene or alkyne easily in one step. It is very difficult, sir. There are steps.
Yes. Yes, good. Good work from your side. And next day, new topic.
The coordination chemistry.
Yes, next day, physical